Hello students, in second lecture on metric spaces we have studied metric defined on Rn set. Today we will study one different metric defined on R2 set. So it is R2. R2 is set of points of form order pairs x5 where x and y are real numbers. Now we will define metric on R2 as for p is equal to x1 y1, q is equal to x2 y2 belongs to R2, d of pq is defined as mod of y1 minus y2 if x1 equal to x2, and we will take the distance between p and q to be mod y1 plus mod y2 plus mod of x1 minus x2 if x1 not equal to x2. Our aim is to show that D is metric for R2. This metric is called as river metric. So, in literature you can read what is meant by river metric and why this metric is called as river metric. So, search for it. Its explanation is given in a book by Taggi, a first course in metric space. We have to check 4 axioms for metric. So first one, M1 axiom, D of PQ is to be mod of y1 minus y2 or mod y1 plus mod y2 plus mod of x1 minus x2 where these x1, x2, y1, y2 are real numbers, their absolute values are non-negative real numbers, means they are greater or equal 0. So even though it is x1 equal to x2, mod y1 minus y2 greater or equal 0 or x1 not equal to x2 for that 2 points, mod y1 plus mod y2 plus mod of x1 minus x2 greater or equal 0. So by definition, D of PQ must be greater or equal 0. M2, we have to check whether D of PQ is 0 if and only P equal to Q. So, for P equal to Q, D of PQ is equal to D of PP. And for this P point, your x1 is equal to x2, y1 equal to y2. So, for same point PP, its x coordinate is same, so to apply y1 minus y2 and it will become mod of y1 minus y1 which is 0. So, for two equal points, D of PQ is 0. For P not equal to Q, case 1, if x1 equal to x2, then y1 must not equal to y2 as P not equal to Q implies D of PQ is equal to mod of y1 minus y2 is strictly greater than 0. Now, if x1 not equal to x2, case 2, if x1 not equal to x2, then D of PQ defined as mod y1 plus mod y2 plus mod of x1 minus x2, this must be greater than 0 as mod of x1 minus x2 is a strictly positive number, as x1 is not equal to x2 in set of real number. Whatever choices of y1 and y2 may be, their modulus values are greater equal 0. So this quantity is a non-negative number, this is non-negative number, and this is strictly positive. That's why d of pq must be positive number. So thus positive axiom hold from case 1 and 2. Case 1 and 2, d of pq is greater than 0 and d of pq is greater than 0 for p not equal to q. Now we have to check symmetry axiom, that is d of pq is equal to d of qp or not. M3 to check d of pq is equal to d of qp. So if x1 is equal to x2, then d of pq is equal to mod of y1 minus y2, which is same as mod y2 minus y1, which is equal to d of qp. If x1 is not equal to x2, then d of pq is mod y1 plus mod y2 plus mod of x1 minus x2. I can write this as mod y2 plus mod of y1 because addition operation is commutative, and mod x1 minus x2 is same as mod x2 minus x1. So I write this as x2 minus x1 here. So this is by definition d of qp. So thus symmetry axiom hold. Thus M3 is satisfied. Now we have to verify triangle inequality. Triangle inequality has more importance while proving some function is metric. Other properties are simple. So M4 triangle inequality. So for this we'll take 3 points in R2. So let P is equal to x1 y1, Q is equal to x2 y2, R is equal to x3 y3 belongs to R2. What is our aim? We have to show that d of PQ less equal d of PR plus d of RQ. Again, here we have to take cases. If for these 3 points PQR, if x1 is equal to x2 is equal to x3, then left hand side is equal to d of PQ is equal to mod of y1 minus y2. Right hand side d of PR plus d of RQ. Again, x coordinates are same, so d of PR is again given by this formula. So d of PR is mod of y1 minus y3 plus d of RQ mod of y3 minus y2. Now mod y1 minus y2 is written as mod y1 minus y3 plus y3 minus y2. This is less equal mod of y1 minus y3 plus mod of y3 minus y2. So if I take this is 1, this is 2, this is 3. From 1 to 3, from 1 to 3, d of pq must be less equal to d of pr plus d of rq in this case. Now case 2, we have to take various cases. We'll take case 2 to be if x1 is not equal to x2 is equal to x3. We'll take this case now. Then left hand side for triangle inequality is d of pq as x1 not equal to x2 for p and q points. So distance between p and q is given by second expression mod y1 plus mod y2 plus mod of x1 minus x2. Right hand side d of pr plus d of rq. Now for p and r, as x1 is different from x2 and x2 coincide with x3, means x1 is also different from x3, means d of pr is again given by second expression. So for that, d of pr will be mod of y1 plus mod of what is the y component of r, that is y3 plus mod of x1 minus x3. For r and q points now, x coordinate x2 x3 are equal, therefore distance between r and q is given by first expression in y coordinates. So it is be mod of y2 minus y3. Now we have to check whether this is less than this, that we have to observe. Here there is x1 minus x2, here there is x1 minus x3 term. Whether that two are equal or not, that you have to check. Okay. Now since x2 is equal to x3, implies mod x1 minus x2 must be equal to mod of x1 minus x3. By using this here, so this is 1, again this is 2, this is 3. Here if I observe, mod y1 term is there, mod y3 is additional term here, and here there is mod y2. Here mod of y2 minus y3. So these two are equal now. These two are equal. Now what about the mod of y2 y3 and y2 minus y3? That you have to check. So for this, this y1 is saying y2 y3 y2 minus y3. Okay. Now mod of y2, I can write this as mod y2 minus y3 plus y3, and it is less equal mod y2 minus y3 plus mod y3. So observe here, this term is less equal addition of these two, mod y3 plus mod of y2 minus y3. So from all these, from 1, 2, 3, 4, from 1, 2, 3, 4, d of pq less equal d of pr plus d of rq. So triangle inequality is satisfied if x1 not equal to x2 equal to x3. Now case 3, if I take now x1 is equal to x2, not x3. x1 equal to x2, not x3. Then we have to check whether triangle inequality is satisfied or not. For x1 is equal to x2, d of pq will become mod y1 minus y2. So this is your left hand side. What is right hand side now? D of PR plus D of RQ. For P and R point, your x1 is different from x3. So D of PR will become mod y1 plus mod of y2 plus mod of, here it must be y3, and here mod x1 minus x3. You have to consider coordinates of P and R points plus D of RQ now. Again for R and Q points, your x2 is not equal to x3. x2 not equal to x3. So what we'll get? We'll get mod of, for R it is mod y3 plus, for Q what is y coordinate? Mod y2 plus mod of x3 minus x1. x3 minus x1, because x3 and x1 are not equal. So we are getting this. Now mod of y1 minus y2. This is less equal mod y1 plus mod y2, and these terms are there. So this part, mod y1 minus y2, so if you observe this expression carefully, mod y1 minus y2 less equal mod y1 plus y2, that are two terms here, and in addition mod y3 is non-negative number, mod y3 is non-negative number, mod x3 minus x1 is non-negative number. So from 1, 2, 3, 1, 2, 3, triangle inequality hold. Now which case remain? Where all three coordinates of PQR are different. So case number 4, if x1 not equal to x2 not equal to x3. Case 4, if x1 not equal x2 not equal x3, then d of pq is equal to mod y1 plus mod y2 plus mod y1 minus y2. d of pr plus d of rq. What is this? d of pr, again these coordinates are not same, so distance between that points is given by this expression. So mod of, what is y coordinates of p? y1. What is y coordinates of r? y3 plus difference between x coordinates x1 minus x3 plus For RQ, again same, mod of y3 plus mod y2 plus mod of x3 minus x2. We'll get this. Again here if you observe, mod y1 term is here, mod y2 is here, and mod of y1 minus y2. Mod y1 minus y2. That term is here. Mod y3, mod y3. Oh, sorry. Here it is x1 minus x2. Okay. Now, mod of x1 minus x2 is equal to mod of x1 minus x3 plus x3 minus x1. This is less equal mod x1 minus x3 plus mod of x3 minus x1. Mod x1 minus x2. x1 minus x3 term is here. x3 minus x2, sorry. This term is here. So if you observe now, this term is less equal to this is less equal this, and this is less than sum of these two terms. So again from 1 to, for these cases I am giving numbering, from 1 to 3 in this case, triangle inequality hold. From all these cases, from all axioms, D is metric for R2. So with this discussion, we'll stop our today's lecture. In next lecture, we'll study more metric defined on again Rn set, R, complex number sets, etc. Or again on set of functions, set of matrices, etc. So today we'll stop here. Thank you very much.